Hi there. How's your climb going?
Hi there, this is Alex from Voiceflow, and today we're going to be doing a bit more of a casual video walking through the Unity AI NPC project I made that's using Voiceflow. If you haven't seen the other video, that's okay. We're going to quickly go over what the project entails and some of its features, and then we're going to do a full walkthrough of how I build this project, all the nitty-gritty, all the details on building these kinds of agents and how I build custom interfaces to help teach you how you can build your own custom interfaces other than just a basic chat box. By the way, all the code for this project and the Voiceflow project itself are available on GitHub in the description below, so definitely go look there. But this video is definitely for a bit more of an advanced audience, maybe developers or something like that. So overall, in this video, we're going to talk about my design of my agent on a Voiceflow side, how I design custom interfaces with my usual Voiceflow interaction and conversation controller system, as well as with choosing a face using AI and then having that show up in the game, and also using AI to generate the spoken voice and to have that be synthesized, as well as tips and tricks and common design patterns for making custom interfaces, and some important reasons for using Voiceflow for building these kinds of agents, like intent classification, entity extraction, which make more organic conversations and would be more difficult to build on your own, or using the knowledge base to integrate lore into our game, and again, an easier way than it would be if you're trying to make our own AI system that's just based off API calls. Just one last note before we jump into it. This is a bit of a crazy proof of concept in a way that I wouldn't recommend trying to do yourself for anywhere near a production deployment. We're having a lot of limitations of things like response time and especially token burn. We are using a lot of LLM tokens to generate all these responses, do all the animations and faces like that. And while this will improve over time, currently it's a bit prohibitively expensive. To try to run this model, it's probably costing a couple dollars per hour of conversation you're having with the agent, which is quite expensive. But this gives you a glimpse of what's possible. In the future, for a real deployment, we'd want to fine-tune a model, have something running on machine or using streaming or things like that to reduce delay. But this is really just to show you what's possible with custom interfaces in Voiceflow to get your creative juices running on making your own great custom interfaces. Let's get into it. So getting you up to speed on what this project involves. First of all, its features are obviously using a large language model to generate answers to a user's question, as well as using AI to automatically choose a face for the character based off a set of multiple faces that are available. There's also voice synthesis using ElevenLabs, which takes in what the character wants to say and then synthesizes a voice for it, both for the character Madeline, but also for a narrator voice.
I just took a break to admire the view.
Other features include also an inventory system where the game can automatically give you an item and then you can give the item back to the character as an example of a different way to interact. So other than just sending a text message, you can also interact with this AI NPC through gifting of an item. There's also reading a journal where you can tell an AI specifically, hey, I want to do this action. It catches that and can then go down a separate path based off that intent to then read the journal. And actually in reading the journal, we're using a knowledge base with custom lore that we uploaded to base our answers off these lore rather than just ChatGPT hallucinating it. Lastly, there's also a background and scene system where we can change the background in the game, but that also affects the context of the entire conversation, which is also used by Madeline in her lore generation to get the correct pieces of lore based off where we are. Okay, so let's go in overall to the structure of this Voiceflow project and how I build the agent. So really we have 4 separate workflows for the 4 separate things that the agent can do. So workflows let us modularize the behavior of our agent, even if overall they're following the same kind of loop. It's going to be generating an answer, it's going to be generating audio and speaking it back. If we want different things to happen, like changing the scene, finding items, or reading from a journal, where we want separate logic, that's when we can use Voiceflow's workflows system to break them up into separate things. So let's start with the home one. Home is just for the general conversation when we're going back and forth and nothing special is happening. So in here, what's really happening is the character is creating its text. Whenever it wants to send it out, it's using this component, send face messages, which we'll dive into a little bit later. And it's waiting on a user's answer. It'll then use a Voiceflow AI step to prep a response to that user's message. Again, using a big prompt, using some memory that we're generating messages. So this big prompt that we custom wrote, send that out again with the same components. So these two do the exact same thing. And then it'll choose if something special wants to happen. It might choose to go to a new place. It might choose to give you a random item, and you could do other things like that. And you could have AI power this choice too, depending on context. Here we're having it done randomly, but you could do it like that. If nothing special happens, it'll just loop back to waiting for the user's response. But if something special does happen, it will jump to those other workflows that handle the logic differently. So let's look at giving an item, for example. Here, when you're being given an item, it's just going to randomly choose an item from a list of possible items. And then it'll create a message that includes this gifted item. It'll have the narrator speak it out. And then it will send a custom action that triggers the gift of the item. It'll then generate an in-character reaction to receiving the item and send it again. So all the flows work a similar way, but this is how I structured my agent for this project. Now, on the other side of it, we have to actually build the custom interfaces that wraps around this Voiceflow agent. So here we're using a Unity project because I wanted to experiment building a different game engine and show everyone that it's sort of possible. So here, from inside Unity, everything is mainly done using the Dialog Manager API, which is something we use in Voiceflow that lets you interface directly with your agent as if you're having a conversation with it, which is exactly what we're doing here. So the actual integration of Voiceflow into our project is done using a Voiceflow controller, which I wrote in Unity. So Unity is C#, and we have the script here where all we feed it is the API key for our dialogue, and then a user ID, which could be, for example, randomly generated when the user installs your game. Here I just have it as an open variable I can set to easily distinguish which user's conversation is going on. And Voiceflow actually has persistent memory. It stores the state of the user's conversation, so if the user went away or restarted their game, you can implement systems that make sure to store that and come back contextually. So inside this Voiceflow controller, if we dive into the code a little bit, it's mainly going to be interacting through the Dialog Manager API like I mentioned earlier. So obviously we don't want the entire game to freeze or requesting an answer from Voiceflow. So we are starting it asynchronously using this coroutine. And the core loop is really this Voiceflow API here. So we're creating the URL with the user ID that we're going to use to interact. And then we're going to be sending requests using Unity's web request library and sending post requests for our Voiceflow conversation. So we're going to include the Dialog Manager API key and some other important information, including that we're using the production version, which is important in Voiceflow. You make sure to specify your version. And then we're going to encode the payload, which mostly is just the text that the user is answering, but it could also be things like a launch payload, which just says, hey, restart our agent in case we want to restart. Here in our scenario, where we are restarting the agent each time you press play. And then here we just have a little bit of handling to handle sending the output and being able to receive it correctly. If there's an error, we will deal with it, but otherwise we will just print out the text we got just to be sure that we got an answer. Then, once we get our answer from Voiceflow, the most important thing when you're building a custom interface is to decide how you're going to handle each type of trace. So whenever there's a step in Voiceflow that's, for example, sending text, or here are custom actions that are used to give replies with faces and audio, or change the scene, or give you an item, or anything that can happen as an output from your Voiceflow agent is a trace, which has a bunch of keys and values that you can use to display. So a text step, for example, has a key that is called message, and the value behind it is the actual body of the message. So if you're making a basic chat box, you can just display whatever is in the message for each trace that has type text. Here we have lots of different types of things that can happen in our agent. So we have some logic that finds out the type of the trace that's being received. So if it's just basic text, it will know to decode the received answer from Voiceflow into this text payload, which we know exactly what to expect. Then we can just respond and handle it using the text response, which is what this handler is doing. So each different type of trace received is being handled differently by the project. So obviously when we receive an order to change the scene, it's not going to be handled the same way as when there's basic text being spoken by the character. If we have face talk, which is a custom action I made, that happens if there's no voice synthesis that could happen for some reason. Imagine there was an error, and we just want to display just a face and text. That's handled differently, so it will just send, again, the face and the message. So we use a slightly different handler. Then if we want to deal with the speech, we, again, store it in a container, handle especially scene change, item change, same thing. And if something goes wrong, which will definitely happen whenever you're making your own custom interfaces, all kinds of extra traces are returned by Voiceflow, like when you jump paths, for example, or when you end your conversation. So you want to be able to find those and handle them like case by case if they occur. So usually that just comes out as here we have a default case. If it doesn't match any of the traces I'm expecting, it'll just print a warning saying, hey, I got this type and not deal with it, which can be useful for debugging later down the line. So just as a recap of how that all works, whenever we want to send something to Voiceflow, we're triggering this function that I wrote for the interact Voiceflow worker with a message response, or actually it's a payload. And the payload could be more than just text. It could also be a button selection or launching the entire conversation from the start. It's then sending that to the Voiceflow using our API as a post request. It's receiving the answer and parsing through every step of the answer step by step. So each of the traces from the response in Voiceflow and handling them one by one, each in their own special way, so that text is handled differently to scene change. So no matter what your use case is, whenever you're trying to build a custom interface using Voiceflow, you're going to have the same basic loop where you're sending a request with a payload, and then you're dealing with the received traces one by one to either print them out in a chat box or have an NPC talk about them in a video game. So Alex, I hear you say, it's all fine and dandy to have a Voiceflow interaction system, but how are you actually sending the text messages to Voiceflow, and how are you handling the flow of the conversation? Well, I'm glad you asked. First of all, from inside the Voiceflow controller, two other important things we have functions that we're going to be using to actually send the interactions. So this is to launch. When we want to start a new conversation in Voiceflow, we have to send a launch payload. So here from inside our C# code, we just have a part that triggers the launch. So when we want to send text to Voiceflow, we have a little function that's just able to wrap the text response from the user and then create a payload to be sent to Voiceflow, and then it will run the interactor function. But all this is being handled by the conversation controller, which is really the mastermind of the whole game. From inside Unity itself, conversation controller has access to all the other scripts that are handling things. So it has access to the Voiceflow controller, the face controller, the speaking controller, the background controller, the inventory controller, even the output text box, which is where we're writing the text on screen to. So this conversation controller sort of coordinates everything that's happening. So when the user decides to click the send button to send their message, it triggers a function here, which then calls the Voiceflow controller to send the text payload, which is just the value of the text field we're writing in, and then update some values. And same thing when you give an item, it'll send a special payload saying, hey, the user gave the item, react to it. The other important thing that the conversation controller handles is sort of the queue of actions to happen. We obviously don't want it to speak all of the character's messages at the same time. We don't want it to display it all out instantly. We want to be able to do that clicking through, continue one at a time. So for this, we make a queue, which is just first in, first out. So when we go through all the traces, we stack them all up to deal with them, and then we take out the first trace, we display the text. When the user presses continue, we go to the next one. So we have a queue of these conversation type actions that can either be sending text or giving an item or changing the background so that they happen at the correct time in the conversation. So whenever the user presses the continue button here, it's just going to dequeue, so take out the last item and handle it one at a time. So that's how each of the handlers is run. And each handler is different for each type of action that can happen. Because obviously the logic that happens when we want to display text is different to the logic that will happen once we want to change the background. So here at the bottom, we have defined these separate handlers for receiving text and speaking it, for changing the background, and these each call all the other controllers that the conversation controller has access to overall. So again, in your own applications, you might have a similar kind of system to this conversation controller that even just keeps a history of all the messages sent to display them all, or handles when things happen one at a time. But often a good way of structuring your own custom interface is to have this Voiceflow controller or Voiceflow interaction script that you can use to send back and forth an interface of Voiceflow and parse the input and output, and then have a separate part of your code that deals with actually the consequences of whatever Voiceflow decides to do. And you'll see this kind of design pattern in all the demos and videos that I've made, and the code that we have on our demos and examples repo follows a similar kind of development flow. So custom actions inside Voiceflow allow us to return our own trace type. So instead of just being basic text or whatever Voiceflow has to offer, you can actually have your Voiceflow agent return something that triggers an action inside your custom interface, just like we would do if we're displaying text, but instead with whatever intent type you want. So here it could be like spray confetti, where you don't need to pass anything, but you can also use custom actions to pass info out with those. So how the same way a text step doesn't just say display text, it actually responds what text you should show. You can here use a custom action. Here we're using a body for item gifting that says actually what item we're gifting. So here we're able to be more creative and expand what's possible in Voiceflow when we want our custom interface to be doing special things. We're using custom actions and passing a payload here with the item and the gifted item that is then parsed on the other side. When we receive this, it's part of the traces that are responded. There's like a payload that comes out, and when we're parsing the payload, this will just come up like any other field. So item will just be one. If we're looking at how we're doing our JSON parsing here, first of all, we described a payload type, which just has a field called item. So that sort of mimics exactly what we're seeing in here. There's a variable called item. Here there's a variable called item. And from inside C# here, we're using newtonsoft.json to actually do the JSON parsing, because JSON parsing isn't super easy in C#, but using these classes, we're able to do it. And then depending on what type of answer we get, so we went over this a little bit before, but we're going to go in a bit more detail now. When we're doing an item gift, so item underscore gift, that's exactly this custom action here. So here, we've been able to make our own type of thing that can happen inside our agent. Here, it's item gifting. And then we're going to use the parser. So that's just sort of this toObject and this type for the payload. It's going to store it into the item payload, which is just specifically parsing the JSON of the trace and getting out, hey, what's the item we want? And that'll be then used for the response handling. And we're actually using custom actions all over our project here. So this is for item gifting, but other things that I can easily think of are, for example, changing scene. We obviously want a custom action that tells our custom interface, hey, change the background. So here it's change scene, similar kind of thing. It has the scene. For things that are more complicated, like speaking, from inside our speaking component, we have a bigger custom action. So face, speech, talk. This has the message that's going to be the text written, the face chosen, so that's the face to display of the character, and the base 64 audio data, which is just the text to be spoken. So if we go back to our code, we'll see again, face, speech, talk, exactly the same name as this custom action. And then the type is a spoken text payload, which then has the face, the message, and the base 64 audio data the exact same way as our JSON. So again, when you're making your own custom interface and you want to have custom actions to trigger special things, this could be even as simple as like opening a payment terminal, which is a common one, or for example, expanding how Voiceflow can display buttons. Instead of just having a bunch of buttons, imagine you could change like an icon for each button or some colors or things like that. You can use custom actions and then your own custom action handlers, which properly extract the right fields you want from the trace and then deal with them in your custom interface. So this is a design pattern I use a lot when I'm making custom interfaces, and I'm sure will be useful for you too. So now let's dive into how the face selection works end to end. So this is the entire system that, based on the text being spoken in other contexts, chooses a face for Madeline to show in the game. By the way, all of these assets that I'm showing on screen are from the video game Celeste. Love the game, great assets. We're using them here just as a proof of concept. So whenever we want to be sending a face message, so that's a message that has, it's a bit of a funny name, but it's a message where we're choosing a face for it. So we're going to be using this component. Components in Voiceflow let us just structure something that we're reusing over and over again. So here, there's lots of different times where we're sending messages that have a face and are going to be spoken voice. So we want that reusable container to be inside of a component. So inside this component, whenever it's going sentence by sentence through the message, and whenever it receives a sentence, it has this big prompt. So the prompt is just explaining some context to an AI. It's giving it a list of choices. It's giving it the message it's reacting to and the message it's trying to classify a face for. In a real application, it would definitely make sense to fine-tune a model to pick these kinds of faces. But here, it's a great example of how we can use LLMs for this. So we're giving it instructions, making it make the choice, and then we're storing it in a variable called raw face. Here we're using a pretty basic model, GPT 3.5 Turbo, for that fast answering, and because we don't want to be burning a lot of tokens on choosing the faces because every single message sent has a face, so it definitely adds up. Once the AI responds, it might respond in a little bit of an unformatted way. It might say like, the face to choose is normal. We want to be able to parse that out so that we just get the exact face to display because it's expecting just normal, sad, angry, distracted. So here we have a little bit of JavaScript that is just parsing out the answer from the AI. If you ever have an AI step that's going to be used in regioning, logic, or custom actions or displaying faces like we are here, definitely make sure to add a parsing layer and try to make it real programming language code other than just asking the AI to format well, because it's not always perfect at formatting answers correctly. So here we're just checking if the message includes what we want to then reduce it down to that. So if it says the face is normal, normal is in there and it'll reduce it all down to just face equals normal. So we do that for each of the choices of face, and if something goes wrong, we have a face called bad that's going to display. It then does a bit of escaping. So then it chooses this face. And when we're sending the custom action to talk, so let's just go to face talk here. In the body, we're going to be storing the face that we parsed up here in the JavaScript, so the extracted face type that we want. We're going to be sending it in the body of the custom action whenever that's sent. So from the code side, that looks a little bit like this. So face talk will come in. It will then know that we have a face talk payload type. So this, it's just going to be trying to take the response trace and storing it into here. And again, we have mimicked here the same schema with a message and a face body. So then when we're in here, it will respond this and it'll pass it to the handler that asks it to talk. So it'll pass the message and the face. So then from inside the Unity project, we have the character here that has its face controller. So with all the possible faces it can show. And this is again some more C# code that will be called by the conversation controller. So then we have the face controller that sort of handles which face is chosen. So then when the face action is actually being handled by the conversation controller, it will trigger this special handle function. And the handle will set the face in the face controller to the specific face of the message. So it will both update the message in the text box and set the face. So this set face function is really simple. It just takes in a face and updates the graphic on the character depending on it. So this sort of end-to-end how we do the face. We generate the face using the AI model, we parse it, we send it with a custom action, we receive this custom action with the specific trace type, we extract the face that we want to display, and then when that specific part of the conversation is being handled, it will trigger a face change and choose the face from the list of assets that it has to update the face on the character itself. For changing the scene, it's the same kind of thing. We're actually using here intent classification so that if a user mentions wanting to change a scene and mentions what scene they want to go to, the AI will be able to extract that. So that uses Voiceflow's intended entities. So here we have an intent that's called changing scene. So if the character says, I want to climb to the summit, it'll extract the summit as an entity, which is like a variable, but just it's captured intelligently. And then it'll use that to set the new location we're going to, generate a reason from the character so they can speak it, and then run a custom action to trigger the change of scene with a narrative message speaking it out again. And then the last thing is on the journal end, we're using the knowledge base. So we're asking the knowledge base to look up documents that might be relevant to what the user said in the context of the current scene. So it infuses in that current scene, which is just a location where the character is right now, to have more contextual answers, which lets us really have a character that's based in the lore of the game instead of just being hallucinating whatever it wants. So that happens here. And then it follows a similar process. It checks out if it's in the knowledge base. If it's not in the knowledge base, it'll just make up something. But if it is, it will speak that through the narrator speaking messages, and then it will send the character's responses with the normal speak face messages. And then each time it loops back to just awaiting the user's next response. And all the other special actions happening are being handled a similar way to how we're displaying faces. The AI will choose something from inside Voiceflow, and then will send a special type of custom action that then is parsed by our Voiceflow and conversation controller, and then we'll trigger the action one at a time, so like giving you the item or things like that. So one thing I want to go a little bit more into is how we're doing the voice synthesis with ElevenLabs. So ElevenLabs is a company that lets you do voice synthesis, which is turning text into spoken voice, and has lots of pre-made voices that we can use. Here, we're using one of ElevenLabs' voices called Mimi, and we have the key for the voice given here. And this is all using inside Voiceflow itself, we're calling ElevenLabs. So this is using a Voiceflow function, which is just a common way of writing JavaScript code inside Voiceflow. We can see it here. That is going to be taking our ElevenLabs API key, the text we want, and it'll actually send the request to ElevenLabs from inside Voiceflow itself. And then it'll do the parsing of that so that we can have the audio associated to each text message from inside Voiceflow when we're sending the custom actions back. So to actually receive the audio, ElevenLabs encodes as an audio MPEG, but custom actions only support returning JSON as the actual action itself. And since we want to have the audio directly linked to the text message in the face, we want to encode it into text. So for that, we're using base64 encoding, which is just a way of encoding binary data, like an MPEG audio here, into some text. So this is just using a text palette, and then it's going to be decoding on the other side. And once it has this base64 audio, we're going to be returning the output variables, which is the audio data. So once this is synthesized from inside ElevenLabs, our C# code in Unity is going to receive it. Whenever the speaking event is triggered, it's going to receive this base64 audio, which is just a string, and then it's going to use the speaking controller to then play that base64 audio. So if we take a look at how that code works up here, we have the speaking controller, which in Unity is attached to an audio source. So we have an object in Unity here called speaking source, which has this audio source here and the speaking controller that has a link back to this audio source. And then whenever it wants to play the audio, what it'll do is it will start it asynchronously. So again, we don't want to be blocking the whole game. So it will decode from a base64 string, which is our audio that we pass back, into just pure audio bytes, which is just an MP3 pretty much. And then we're going to export that to an MP3, which is stored temporarily to have it all in one place. And then we're going to then stream the audio from that MP3 to the audio source. So here we're doing just a local file streaming, which is just a workaround in Unity to get a temporary file streamed correctly. And then it will then update the audio source to be this streamed audio file that we then generated based off the audio from ElevenLabs, and it'll then play that source. So end to end, for the voice synthesis, we have a function inside Voiceflow that takes the sentence we want to read in as input text here, and the voice we want in our ElevenLabs API key, calls ElevenLabs, synthesizes it, encodes that audio into base64. That base64 audio is returned with a speech talk custom action, as here, base64 audio. That's then received by our C# code, and then decoded, stored, and played from inside the game. So you can imagine similar kinds of patterns if you want to make your own audio synthesis or any other kind of API call, where then you're going to be using that resource in your custom interface. So one of the features of this proof of concept is whenever the user asks the character to read from their journal, it can trigger that kind of reading journal action where they pull lore from the game and give a special story, which is handled differently to other things. And intent classification is actually a pretty difficult thing to do when you're making your own agent by just using interactions directly with APIs like ChatGPT, for example. But here, Voiceflow has built-in intent and entity classification for us, which lets us understand what the user wants to do if they want to go down a special path, like, for example, reading journals or changing the scene. So here, for example, reading journals is not too complicated of an intent. We just give it a bunch of example phrases, and whenever the user says one of those utterances, the Voiceflow system will automatically detect it and bring us down this special read journal path with the trigger, which is the read journal intent. A more complicated intent classification is, for example, to change scene. We have the functionality where the user can say, hey, I want to go to a specific location, so I want to go to this summit. So that's an intent, but we also need to extract the entity, which is where they want to go. So that is done using the entities system. We have an entity made for the mountain scenes, which has all the different places that the character can go and other synonyms they might use to refer to them. And then from the intent, we have a change scene intent. So where the user can just say, hey, let's go somewhere else without specifying one. But the user can also say, hey, I want to climb to this specific spot. So here Voiceflow is going to use its entities and intent system to first of all capture that the user wants to change location, change scene, and then extract the entity, which is where they want to go. And that's again used inside the specific change scene workflow. And here we can see that we're copying out the where they want to go, which is that mountain scene entity, to the chosen next scene. Sometimes it might also randomly choose to go to another scene, and then we just set this manually. But this is something that would be really non-trivial to make on our own, but that using Voiceflow as our platform to make our AI agent on really helps. So I think you could see how you could use a similar kind of thing in your own use case. For example, in e-commerce, a user might want to trigger an intent that has to do with customer support or asking about a certain item. So let's say it's asking, hey, does this skincare product contain a certain kind of chemical? And it's going to be able to understand, hey, the user is asking about skincare products and what's in them, and it's able to extract exactly which skincare product they're talking about. Another feature that's really helpful to use Voiceflow for here is integrating lore into our agent. So instead of just having ChatGPT hallucinate whatever it wants about wherever we are and not be really founded on our story, for example, in this game design scenario, you might want to embed documents you have about the story of the game to really make the answers richer and canon and following the actual narrative of your game. So here in my knowledge base in Voiceflow, I uploaded a bunch of text documents with lore about our game. So like the mystical origins of the Celeste Mountain. So when Madeline is answering your question to read your journal, she can use the contents of your knowledge base to base her answers off of. And that's being done here through the read journal flow, where whenever you're asking a question, it's going to look it up in the knowledge base. So it's going to, instead of just using just a raw AI model here, it's going to be using the knowledge base and the user's utterance and the current location, so that the character can give scene relevant answers instead of just talking whatever it wants. So again, here we're seeing that through building this on Voiceflow with all these variables, it's really easy to incorporate things like the current scene. I just had to add a little bit of extra text in the context of curly braces, the current scene. So it's doing this knowledge base lookup of all the lore, and then using here GPT-4o and some information about the character to formulate an in-character response to what's going on. And we're able to prompt engineer and build whatever we want. And here Voiceflow makes it really easy to do this kind of lore integration, where maybe your own organic system, you'd have to spin up your own vector database, handle all the logic for it yourself. Here, the only logic handling we have to do is if an answer is found in the knowledge base or not. Sometimes if the user is asking a question that can't be answered, you could have the character say, oh, I can't find an answer to that here. Here, I'm just going to have the character make something up. So I'm just having ChatGPT hallucinate whatever it wants as a fallback. But here, the core emphasis is really on lore. And then regardless, it's going to be sending it as a narrative message saying like, Madeline opened her book, which is set here. So Madeline cracks open a journal and reads from it. And then it will just send the text message out to be spoken. So one thing that's pretty obvious while going through this project is some of the limitations, especially when it comes to delay and prompt cost. Right now, I'm just working on making a proof of concept, but if you're trying to do real deployments like this in real world scenarios, I would really encourage you to focus on things like optimizing your prompts to be as short as possible, and maybe implementing things like text streaming. Voiceflow has recently added the ability to stream responses. Instead of waiting for your LLM to give its entire response, you can stream things one at a time, which might reduce delay, or you can use things like ElevenLabs streaming API to stream the audio in real time instead of waiting for it to all be synthesized one at a time. But this sort of shows what's possible with Voiceflow, and I'm sure that many of you will have creative solutions in your own use cases. And really, for most custom interfaces or use cases that you guys are going to be using, these should not be too much of a limitation. Waiting a couple seconds for a text response to come back out or for things to be triggered isn't too big of a deal, but it's just something to think about in the background while you're developing your project. That was quite long, but I hope we went really into depth about how I make my custom interfaces and how you can use a similar kind of framework to make your own. As usual, all the code for this project and the Voiceflow project itself are on a GitHub in the description below. And if you're building your own custom interfaces, I really encourage you to give them a look, either at this project, at its code. If you're not writing in C# though, we have other examples that I've made, like with my article reader that's in React, or other things made in Python. We have a huge repository of demos and examples using Voiceflow. So when you're making your custom interfaces, I really encourage you to iterate on those. Also, definitely take advantage of the online community, Discord, and all the resources we have about Voiceflow, and our developer docs, which can really help you make these creative custom interfaces. And hopefully after this full tutorial, or not really a tutorial, but more like a walkthrough, you've been able to learn a lot about how you can make them. And if you make your own custom interfaces, definitely make sure to share them on social media and tag Voiceflow or put it in the comments in the video description. I would love to see them. I hope you enjoyed, and I'll see you around.